Thanks for welcoming me today. So I am Daniel Wynn, the CEO of Matrix Security, and I will show you how we can deploy Onyx models with privacy guarantees. Can I share my screen? Yeah.
Did you take control at the top?
Where is Oh yeah, thanks. Okay. Does it work? Yeah. You get used to it. Okay. Yes. So the issue we address at Matrix Security is the fact that we might want to deploy AI models, especially in a cloud setup. For instance, imagine you want to use AI to screen patients using deep convolutional networks. But the issue we face is that when we want sensitive data to be analyzed by other parties, we need to trust them with the data, especially in cloud scenarios, where we need to trust both the AI companies that will deploy the model, but also the cloud providers. And sometimes for regulation, privacy, and security reasons, this can be an obstacle for the adoption of AI. And so you might think, what is the issue? If, for instance, I use TLS, isn't that enough? But we see that the problem is at the last mile during analysis. So, for instance, we can imagine that this hospital wants to use this COVID screening as a service. So they get the data locally on the device. They can encrypt it. Then what happens is they will send it through regular channels, for instance, a TLS channel, and the data can be sent there, and it will be decrypted. So this is like regular stuff, but this is a problem. At that specific moment, because we needed to decrypt the data is available both to the cloud provider and the AI provider. And it is because at the last mile, the data is accessible. Any malicious insider can dump the data, get access to it, and therefore the data owner has no longer guarantees that his data is safe, because at that specific time when data needed to be analyzed by the AI, it is exposed. And because we have no control of that, this is a huge issue to trust external parties with the data for AI training or deployment. So that's why at Matrix Security, you have developed Blind AI, which is an open source and secure solution to deploy Onyx models inside what we call secure enclaves, which are solutions that leverage hardware to protect data. So what is the difference? Data will be decrypted inside this enclave, but the idea is that this enclave, which are hardware-based technologies, provide isolation and encryption of the memory content of the enclave, and so any dumping attempt for the outside will abort. But while data is still inside the enclave, you can do whatever you want, including applying, for instance, an Onyx model. So this way, you can analyze that inside a secure environment, but it's not accessible to the outside. And for instance, here you can get a result. You can then re-encrypt the data and send it back to the user so that they can benefit from it without having to trust a third party with their data in clear. But the best part is that they did not need to deploy the solution locally. They could resort to an external cloud solution. So it's very easy for them to be onboarded. And for the AI provider, it's very easy to maintain and sell a solution. So how does it work in practice of architecture? The idea is that we have an Onyx engine. We are using Tract, which is Rust-based Onyx engine initially for embedded devices, but we've modified it to make it work inside a secure enclave, and then provide some networking abilities for data to be analyzed. And then we have wrapped everything inside a Docker image, and then we have several several cloud SDKs to securely consume a remote model. The idea is that by leveraging the Onyx format, we make it easy to deploy AI models with privacy guarantees. You can easily deploy our Docker images, for instance, in Azure using a confidential VM. Then with our Python SDK, you can securely upload your Onyx model. For instance, here we put a Distilbert model inside of this. And finally, with the same Python SDK, you can securely send data to be analyzed without the third party having access to your data. And really, by leveraging the Onyx expressivity, you can see that it's quite smooth and resembles existing solutions. And because Onyx is able to cover a lot of models currently, thanks to its expressivity, we're able to cover a lot of use cases. For instance, baggage screening at airports. And for instance, for that, we help a client use a YOLO model. We also help other people use NLP to analyze medical documents to save times for hospitals. In that case, they use the BERT model. And finally, we can also cover, for instance, facial recognition, because our model also covers, our loader also covers ResNet's model. And so what do you see in terms of difference of speed when you are inside an enclave? So here I show you different models that are quite used in practice, and the inference time with our inference engine in Rust outside of the enclave, and the inference time inside the enclave. So you can see that there is an added let's say latency, but it's let's say reasonable given the added protection we provide. And we can discuss this later. But also one thing I did mention, that we are actually able to put huge models inside enclaves, and we have done testing, for instance, with GPT model with 3 billion networks, and it does work under a second. So it's very promising to enable people to consume AI models that will not be able to deploy on premise, but still send data and have protection guarantees on their data. And finally, the good thing with using Onyx is that you need a minimal code base to apply AI models, and contrary to having a generic Python solution, by using just an inference runtime, you can have a little code base that is better for security reasons, and also you can reinforce each operators to make them what we call side channel resistance, which means that we try to avoid leakage to the outside, even though we are using a secure enclave. So I am done. Yeah. So if you are interested by our solution, you can contact us, and you can also have a look at our GitHub. Our solution works from end to end, and we have various scenarios that we can cover. I think I've left some time for questions, but if not, I can also dig deeper into the technical security details, or I can stop here.